This is class 7th NCERT, chapter 3 of science, NCERT of science. So we all experience hot and cold according to the environment, according to the season, right? So accordingly you change your clothes, you wear woolen clothes and during winters, and obviously the light colored clothes during summer. So basically in this chapter we are going to deal with this. We will seek the answer to some of the questions that how do we know whether an object is hot or cold, and then how do we find out that how hot or cold an object is. Generally, how do we measure that? We often do it by touching the objects, right? But we can just give the sense of hotness and coldness, that this is much hotter than the other one, or this is colder than the other one, but we cannot give it a quantity. We cannot measure it in the quantity. First of all, this is our limitation. The second limitation is that if the thing is very hot, that we even cannot touch it and sense it. So the next question is that how can we measure the things, right? So that is where a device is used, and this is known as thermometer. The temperature is measured by a device called thermometer. Now we are going to see that how we measure the temperature by a thermometer, and what are the limitations of each kind of thermometer. So you must have used your clinical thermometer at your home or at the doctor's clinic, which measures the temperature of the body, right? And it looks like this kind of thermometer, but nowadays you get a digital thermometer also. We will talk about it a little later. But a clinical thermometer, a traditional clinical thermometer which is mercury based, looks like this. To examine you, what doctor does, doctor put this thermometer below your tongue. This is the bulb of the thermometer, right? This part is known as the bulb of the thermometer. So this bulb is put it inside of your mouth, and accordingly the mercury level, this area contains some mercury. So the mercury level expands according to the temperature, and this expansion of the mercury level inside this capillary, this glass tube, the very thin glass tube is known as capillary tube. So this capillary tube contains what? It contains mercury, and the mercury gets, as it gets hotter, it expands. After 1 minute, mercury level which was expanding inside your glass tube, that stabilizes, and now you can take the correct reading. So till where the mercury level reach up to, suppose, this point. So you read at the side of this capillary, there is markings, there is calibration. This marking like this, these are known as calibrations, right? So calibrations. So accordingly you get the quantity, accordingly you get the measurement of temperature in some quantity, right? So suppose it is 40 degrees Celsius. So you get that your body temperature right now is 40 degrees Celsius. Now suppose if I ask you to use this thermometer and measure the temperature of ice water, the water which is as colder as your ice, or measure the temperature of what? A very hot milk, very hot milk, very hot milk. So what you will do, you will go and put this bulb inside this hot milk or inside this cold water, and you will try to read the reading of the thermometer after 1 minute, but it will not work. It will not give you the correct reading, and it will not work. Why? Because this is the limitation of this clinical thermometer. Clinical thermometer are designed to measure temperature between 35 degrees Celsius to 42 degrees Celsius only, because these are meant for measuring the human body temperature only. So these are meant for measuring the human body temperature only. So these are not devised in a way to go beyond this. So now let's learn how to read a thermometer, right? First of all, before using thermometer, there are some precautions which we should observe, and these are: thermometers should be washed before and after use, preferably with an antiseptic solution, right? Then ensure that before the use, the mercury level is below 35 degrees Celsius. Yes, sometimes suppose you are going to use your thermometer, and first of all you will see that the mercury level inside this tube, the mercury level inside this tube, now here you will find some calibrations, and this is suppose 35 degree. The mercury level inside this tube was here. So you will ensure that this mercury level should be below this marking, below this 35 degree Celsius. This is not 350, this is 35 degree, right? So you should ensure before using that this mercury level should be somewhere below 35 degrees Celsius, right, in this area somewhere. So how you will ensure that? For that you must have seen that either doctor or your parents would be jerking it so that the mercury level gets down before using it, right? Once the mercury level gets down below the 35 degrees Celsius, and then you use it as it is, right? Then there are some other obvious precautions, and you can read it on your own. Yes, it is very important that don't hold the thermometer by bulb. By bulb, this is bulb. Suppose this is the bulb and you are holding it like that. So, this is the point from where the heat is transferred to the mercury, right? So keep it in air. Otherwise, it can change the level of the mercury very fast, and then it can, destabilize the mercury level, and you will get the wrong reading. There are the chances. So that's why you need not to hold this thermometer from the bulb. Now, let's get the more idea of how to read this bulb, this reading. So I am zooming out that area, suppose the mercury level reaches, this is your mercury level, now this was 35 degrees Celsius, now this is degree Celsius line, and this was 35, then 1, 2, 3, 4, then this was 36, then 1, 2, 3, 4, and this was 37, 1, 2, 3, 4, 38, and so on. Now, I just want you to read this thermometer perfectly. How will you read it? So just like you read your the length of a line from your scale, so similarly you will have to read it here, but there is something you need to get an idea of. So what is it? Now you will see that the mercury level is up till here 37, and it goes even beyond 37. So how far is it from the 37? You see that this is 3 point. So can I write it like 37.3 degrees Celsius? Can I write it like this? Because in scale you will find that if this is the length of the line, you will write 37.3 centimeter or millimeter, whatever it is, right? But can we write it here like 37.3 degrees Celsius? No, this is wrong. This is not correct. So then what would be the correct measurement? Now see, how will we define that this gap is equal to how many degrees Celsius? This one point gap is equal to how many degrees Celsius? This we will have to measure it here first. So see, there are 5 divisions. 1, 2, 3, 4, 5. There are 5 divisions, and in 5 divisions there is, just apply unitary method. In 5 divisions there is how many degrees Celsius change? There is change of, in 5 division there is a change of how many degrees Celsius? 1 degree Celsius. In 5 division there is a change of, because 37 to 38 degrees Celsius, that is 1 degree Celsius. So in 5 divisions there is a change of 1 degree Celsius. So obviously, therefore, in one division there will be the change of how much? There will be the change of 1 by 5 degrees Celsius. That is, if you divide it, you will get 0.2 degrees Celsius. Now, so in one division there is a change of 0.2 degrees Celsius. So now we are where? We are 3 divisions away from 37. We are 3 divisions away, right? That's why we had written that 0.3. So we are 3 divisions away from 37 degrees Celsius. So 3 divisions away from 37 degrees Celsius, that means 3 into 0.2. So therefore, in 3 divisions, there is a change of 3 into 0.2, that is 0.6 degree Celsius. So now we will add 0.6 degrees. So it will not be 37.3, but 37 plus 0.6 degree Celsius, that is 37.6 degree Celsius. So this is the correct reading. So generally you will find the body temperature remains at 37 degrees Celsius in general. Let's get what is written in that bubble. Bujo got a naughty idea. He wanted to measure the temperature of the hot milk using a clinical thermometer. Paheli stopped him from doing so. Why Paheli stopped him? Because Paheli knows that the clinical thermometer are designed to measure the human body temperature only, and its limit is 35 degrees Celsius to 42 degrees Celsius. Yeah. One thing I want to mention here that there is another unit which is written over there. You will find on the calibration of the thermometer that it is the unit which is known as Fahrenheit, right? So the range in the Fahrenheit is 94 to 108 degrees, right? And this is known as Fahrenheit scale. So you should notice it also. You should see the thermometer. If there is a mercury thermometer in your home, then you should take it out, but with care, and just see it whether you find there these two scales or not. So Paheli stopped him, and Paheli said that we have another kind of thermometer which is laboratory thermometer, and we cannot use clinical thermometer. This is the caution for clinical thermometer, that it should not be used for measuring the temperature of any other object than the human body. Avoid keeping the thermometer in the sun and near the flame. It may break because of the heat. It is designed for very limited temperature, and if you want to take it for suppose beyond 50 degrees Celsius, 100 degrees Celsius of temperature, if you are going to measure that kind of temperature, then the expansion of the mercury can exceed, and the expansion of the mercury will be very large, and it can break the thermometer away, right? So that's why it is a caution. You should not use it for any other purpose. So for any other purpose, we have the laboratory thermometer. And how the laboratory thermometer is used, let's see that. So suppose in the similar way you want to measure, you want to suppose first of all, let's see what is the range of the laboratory thermometer. This is 10 degrees Celsius minus 10 degrees Celsius, not 10 degrees Celsius. It is minus 10 degrees Celsius to 110 degrees Celsius. The more the range, the more amount of temperature we can measure. So minus 10 degrees Celsius. So even we can measure the temperature of an ice water comfortably from this kind of thermometer, and even we can measure what? A very, very hot milk temperature too, right? So suppose I want to measure the temperature of this hot milk. How will I use this thermometer? See, this is the bulb of the thermometer. We will take it to the beaker where the hot milk or the ice cold water is contained. We'll dip that bulb here completely, and we should ensure this time that the bulb is completely submerged, surrounded by the object whose temperature we want to measure. So this bulb should be completely surrounded by the object whose temperature we want to measure by this kind of laboratory thermometer. So we will dip it completely, right? And then we will watch the mercury level inside this kind of thermometer. So we will see that the mercury level inside this thermometer will move like this. It is moving up, but it will continue to fluctuate like this, right? And we will have to keep it in the upright position like this. We cannot just put it like this or this in any direction, right? We will have to keep it upright, and then we will watch that the mercury level is continuously going up, but every time it is moving in this way. So it is fluctuating up and down. So once this fluctuation stabilizes after some time, we will get an idea that now we can measure the temperature, right? At this moment we can measure the temperature. Keeping this thermometer inside the beaker or an object whose temperature we want to measure, and in this very position we will note the temperature once this mercury level get stabilizes, right. Now see the difference when you was measuring the temperature using the clinical thermometer. You are taking it out and then you were measuring it. Suppose the same method if you use here, that once you put it inside the beaker, now the mercury level starts increasing its level. If it is hotter object, if it is colder object, that then obviously mercury level was suppose there, and now it will start moving like this downward, right. And once it stabilizes, then you can measure it as, keeping your thermometer as it is dipped inside the submerged inside the object. But suppose if you take it out and now you want to measure it just like you measure the temperature using your clinical thermometer, what you will find that the moment you have taken it out, you will find that the mercury level again starts fluctuating immediately, right, and then you will get a wrong reading. But this does not happen in the clinical thermometer, because you will have to get the reading in the clinical thermometer by keeping it at your eye level, right. So what is this difference? Actually, I want to ask you that what is there provided in the clinical thermometer which is preventing the thermometer mercury level from falling off on itself? Because if you use the same method that you will draw out the laboratory thermometer and then you will measure the reading of the thermometer, what you find that the moment you take it out of the beaker, it will start fluctuating and then you get the wrong reading. But because the mercury level starts falling down on its own. But this does not happen in a thermometer, in a clinical thermometer, because there is a method of measuring it, keeping it at your eye level. So what extra thing is provided in the clinical thermometer which prevents the fall of mercury on its own the moment you take it out from your mouth? So that is, you should know here, there is a kink. Right? So there is a kink. You might have noticed that initially when I made a thermometer in the above page, I intensely had shown you a capillary like this. This is not from the red color, I am making the capillary. Inside this capillary is contained what? That mercury. So this is capillary tube inside the glass tube. So see, this turn is provided in this capillary. This is known as kink, and this prevents your mercury level to fall on its own. Now there is a bigger science that is related to cohesive force and surface tension, which can be explained to you in the later classes when you will reach till this concept of surface tension, right? But for the time being, you can understand that there is a turn. So this turn acts as a constriction, as a एक तरीके से ये मोड़ बन जाता है, जो मोड़ से, जिस मोड़ से सपोज एक तरीके की रुकावट बन जाता है, दैट इज कॉन्स्ट्रिक्शन, राइट. So it provides a kind of constriction to your to easy flow of the mercury back downward, right? So this provided a constriction, and we call it capillary break also. It provided a kind of capillary break, and this kink is not there in your laboratory thermometer. So this kink prevents mercury level from falling on its own. But see, this mercury used inside the traditional thermometer, right, this is toxic in nature, right? This is toxic substance. So once your thermometer breaks into pieces, so mercury gets released into the atmosphere, right, and it is very difficult to dispose it if the thermometer breaks, right, because it is toxic. If you just dispose it as it is, so it will harm the environment. So nowadays these kind of thermometers are replaced by these kind of digital thermometers, right, which do not use mercury. Then you will ask me, then we just have read the whole concept of thermometers and now it is not using mercury, then how does it works? It works on the principle of, as I said, this is digital, so it uses what? It uses semiconductors, just like the semiconductors used in your mobile phone, right? All the digital devices uses this semiconductor, which is not in your syllabus to read now. It is higher classes syllabus. So it is just like that. Yeah, you can ask me, then now these kind of thermometers are also used in the similar manner, like you will put it inside your mouth, then you will have to read it, read the temperature, taking it out from your mouth. Then what the role of the kink role which was being provided by the kink here, right, to keep the temperature stabilized once you take it out from your mouth, that role is being that role is being performed by which object here inside the digital thermometer? I think it's very clear that similar manner, if there is no kink, suppose there is no kink and there is no object, there is nothing else which is doing the same, which is performing the same role which the kink was performing here. Kink was performing the role here to keep the mercury level from to prevent the mercury level from falling on its own, right? This was the role. Now once you take it out, if there is no kink, there is nothing else which is substituting the kink in the digital thermometer, then obviously here we will not get the correct reading once we take it out of our mouth. So what that object which is performing the role of the kink? I think the question is clear. So that object, let me tell you, is the memory card, right? So in all the digital devices you have what? A memory chip kind of thing, which can store the data, right? So similarly, there is a memory chip in this digital thermometer which can store the data, and for very small period, because its memory is not in GBs, 1 GB or 10 GB, it's very small memory, so that you can have a display for some seconds once you take it out of your mouth. That's it.